Salam sejahtera to Dr. Aizuddin and everyone. We are from Group 2 and our group members are Asif, Zaro and me, Lee. We will present the reports of experiment 4, that is the application of first and second law of thermodynamics.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zarul Azam. So today I will present for introduction part. This experiment was set up to prove the first law of thermodynamics and the second law of thermodynamics. This experiment only involved tap water, which is 28 degrees Celsius, and hot water 80 to 90 degrees Celsius. This experiment starts with 0 minutes until both temperature of tap water and hot water reach equilibrium temperature. So we have set two limitations here. First, the temperature of two materials, and second is the time taken for the temperature for both temperature of tap and hot water to reach the equilibrium. So now we move to theory. For this experiment, there will be two laws that involved in this experiment. First, we have first law of thermodynamics. Second law of thermodynamics. The definition for the first law of thermodynamics is energy can neither be created nor destroyed, only altered in form. The definition for second law of thermodynamics: entropy, the state of entropy of the entire universe as an isolated system, will always increase over time. So next, Lee will continue their presentation.
Salam sejahtera, I am Lee and now I will continue the presentation on the materials and apparatus parts. There is only one materials in this experiment, that is tap water, and there are 6 apparatus in this experiment. The first one is magnetic induction heater plate. Second one is 2 beakers with different size, and next is heat resistant glove, weighing scale, thermometer, and last one is retort stand. Now I will present the procedure of this experiment. 2 beakers with different size is weighed and the mass of both empty beaker is recorded respectively. Tap water is added into both beakers, then is weighed again. The mass of the beakers is recorded. The initial temperature of water in large beaker is recorded. Water in small beaker is heated with induction heat plate until 80 degrees Celsius. After water in small beaker reach 80 degrees Celsius, small beaker is carefully removed and put into the large beaker that containing the tap water. A thermometer is placed in the hot water beaker. Temperature of water in both beakers is recorded every minute. Stop recording the temperature of water in both beakers until they reach the stand temperature.
So here is a result for this experiment. We start the experiment with 0 minutes, and temperature of the water is 28. Temperature of hot water is 80. We will measure the temperature of tap water and hot water for every 1 minute. So for the first minute, the temperature of tap water is 41. The temperature of hot water is 72. For second minute, the temperature of tap water is 46. The temperature of hot water is 66. For the third minute, the temperature of tap water is 51. The temperature of hot water is 62. For the fourth minute, the temperature of tap water is 52. The temperature of hot water is 60. For the fifth minute, the temperature of tap water is 54. The temperature for hot water is 58. And for the last minute, which is 6 minutes, the temperature of tap water is 55. The temperature of hot water also 55. For we have plotted the graph time versus temperature tap water and hot water. So we can see the trend for temperature tap water is increases, while the trend for temperature hot water is decreases until both reach the equilibrium temperature. So here we move to calculation part. We need to calculate a few things using data that we recorded. So first thing first, we need to calculate temperature changes of hot water. Delta TH means delta temperature hot water. How to find it? Temperature hot final subtract temperature hot initial. The answer that we get is negative 25 degrees Celsius, which is it is uh, it is exothermic. Next, delta temperature tap water. Uh, how to find it? Temperature tap water final minus temperature tap water initial. The answer that we get is 27 degrees Celsius, which is it is endothermic. Next is energy changes for hot water. So the formula is mass times specific heat capacity times difference in temperature of hot water. So the mass is 0.19487 kg times 4.187 for specific capacity, and the temperature is negative 25. The answer that we get is negative 20.39 39 3980173. So next is we calculate the energy changes for tap water. So the formula is same, mass times specific heat capacity times difference in temperature of tap water. So the mass is 0.2591 kg times 4.187 kg of unit kj over kg times k, and then the difference, the delta tap water is 27. The answer that we get is 29.291. And lastly, we will calculate the total energy change in the system. So the energy changes of tap water plus energy changes of hot water. So the answer that we get is 8.89 297 8.892979. So next we move to the safety procedure.
Hi, hello, my name is Muhammad Asif Izrail Besharuddin. I will present about safety procedures, discussion, conclusion and references in this lab report for the experiment 4, which is the first and second law, the application of first and second law of thermodynamics. Okay, the first one is safety procedures. This is the procedures that we followed throughout the experiment in order to avoid any unintended accident from occur. The first one is we wear a lab coat throughout the experiment, and we also wear glove when handling hot beaker in order to avoid direct contact from our skin to the heat. And the next one is the next one is the discussion. This is the data that we observe during during and after the experiment. The observation that we managed to observe, which is there is a relationship between the temperature of water, which are tap and hot water, until it reach thermal equilibrium. What I mean is there is a changes there is the changes of temperature of tap and hot water, and which is hot water. The temperature of hot water will increase over time, and the temperature of tap water will decrease over time until it reach one point that they do not increase and decrease. They will steady in steady state because they already reach thermal equilibrium. Before that, we plot the graph time versus temperature, tap and hot water. We plotted the graph from the data that we took during the experiment. And the last one, what we observe is there is an application of thermal equilibrium, because the heat energy is because there is a changes of heat and temperature, which is because the heat energy is transferred between hot water and tap water, from hot water to tap water. And from the graph, there's changes of heat energy from hot water to tap water, like I explained before. And there is an application of first and second law of thermodynamics during the experiment. And for the conclusions part, the conclusion that we can conclude during the experiment is the energy of hot water and tap water was, and for the hot water, negative 20.3980173 kilojoule, and for the tap water was 29.291 kilojoule, which we calculated using MC theta formula. There is and heat was transferred from hot water to tap water in this experiment until it reached thermal equilibrium. And the application of first and second law of thermodynamics is used in this experiment. Heat in hot beaker that had been lost during the experiment due to conduction is neglected. Heat in hot beaker, which is there is a slightly heat had been lost during the experiment, and there is one main error occurred during the experiment, which is parallax error when we taking and reading the measurements of thermometer. So the solution is to make sure the eyes of observer is perpendicular to the thermometer when taking the measurement. Alright, next, the last part and the last one from our group is references. These three references we referred before we conducting this experiment and before we making the proposal for the experiment. And I think that's all from us, from group 3. Thank you very much.